Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the May-June 2020. This is the Cambridge 0580 IGCSE paper, paper 4, variant 3. And this question here is all about trigonometry. And here we have a triangle inside another triangle. It shows triangle ABC, which is a big triangle, with a point G inside it. And they've joined G to C and G to B, and they've got these following lengths. CB is 11, CG is 5.3, BG is 6.9 centimeters. Angle CAB is 42 degrees, and angle ACG is 54 degrees, and we need to find the value of the angle X. Now, angle X, I've got the diagram here, so we've got a bit more space instead of scrolling up and down all the time. You see angle X is inside this triangle, BCG. Okay, so BCG, this triangle here, we have angle X. So this angle is an angle in a triangle, which is not a right angle triangle. So we can't use SOHCAHTOA. Can't use like sine, cosine, and tangent like as they are, opposite over adjacent. We don't have any right angle. We don't have any hypotenuse like that now. But we have a triangle where we know all three sides. Now, whenever you have all three sides in any type of triangle, and you want to find one of the angles, you can use the cosine rule. And the cosine rule, there are two formulas associated with it. A squared equals B squared plus C squared minus 2BC cosine of A. Now, I would use or start with this formula if I'm going to try to find a side, and I know two sides and an angle between. So if I'm trying to find, for example, this side, and I know this angle, I know these two sides, I would use the cosine rule in this form to find a side. To use this to find an angle, it's basically the same formula, but if you rearrange it, this is what it looks like. You got B squared plus C squared minus A squared over 2BC. It's basically you've made the cosine A the subject of the formula. So you added this to both sides, subtracted A squared, then divided by 2BC, you got this formula. So if you actually memorize your formula like this, when you're trying to find an angle, that makes life very easy for you. But you have to understand what it means or how to use it, how to apply it. Basically, what's important for you to realize is that these are opposites. This angle and this side must be opposite each other. Okay, whatever's here, whatever's here, doesn't matter what name they have, C, A, B, G, H, whatever it is, as long as this angle that you're trying to find, okay, is used with this side, which is opposite it, we have to deal with that. That's how you can find what you're looking for here. It's very important for you to understand that these must be opposite each other. The angle you're trying to find and the side that's in this place in the formula must be opposite. So let's proceed with this. So we can say the cosine of the angle we're trying to find, which they've called X, is equal to, so for B and C, it's the other two sides. It doesn't matter which way you write them. I can put 11 or 5.3 first. It doesn't matter. So let's just do it. 5.3 squared plus 11 squared. There's a minus here. So minus the side opposite the angle we're trying to find squared over 2 times those other two sides, okay, which are these two, not the A, the other two sides. So 5.3 times 11. When you write this, this is your method mark for the cosine rule. You don't have to actually write down what this and that gives you and all that. You can just write X equals and put your answer down. Okay, so what you do here is you use your calculator and you make sure you're in degree mode, which we are. If you're not in degree mode for this calculator, you can just go to angle unit and choose 1, 2, 3. We want 1 degree. Very important because your answer will be wrong if you're not in degree mode. And then you put inverse cosine. So press shift cosine, fraction button. Don't forget to square these ones. So 5.3 squared plus 11 squared minus 6.9 squared over 2 times 5.3 times 11. And then close the bracket, press equals, and you end up with 29.503, 29.503. So I'm going to round it to 3SF, so 29.5, and that is in degrees. Okay, 1 decimal place for angles in degrees. Okay, you round it unless otherwise stated. So if it came out as a 1-digit number like 9 point something, you'd write 9.5, for example. If it came out as a 3-digit answer, like a number bigger than 100, like 295, you would here put 295.0. You would round it to one decimal place. But in this case, 29.5, that's one decimal place. And there we have the answer to part 1. Okay, so how to apply the cosine rule, very important for us to know that. Now, part 2 is a bit more involved. It says, calculate AC. Now, we worked out what this is. Okay, we know that the value of this angle is 29 point. I'm going to write it not as 0.5. I'm going to write it 0.503. You should always keep a higher degree of accuracy in your working. So we know that the angle, that's what we know so far from before. So it says calculate AC. This is AC. Okay, this length is what we have to find. For example, let's call this Y. We already used, X is already used, let's call it Y. All right, we can say let, okay, Y be AC. Okay, so I don't have to keep writing AC every time. Now, I want to find this side. I can think about this big triangle now. Think about this big triangle here, ABC. So the big triangle is A, whoops, going off the tracks a bit, ABC. Okay, that's the big triangle here. Okay. All right. Now, in this triangle, I have one pair of opposites. I'm always looking for opposites, even for the cosine rule, the sine rule, they help. So I've got one pair of opposites that I know. I know that this is one pair of opposites. I want to find this side. Okay, I want to find this side. Okay, and that means I need to know, if I'm going to use the sine rule here, I can't use the cosine rule because if I'm trying to find this angle, okay, or this side, I need to have the two sides and the angle between them. So I don't have enough information to find them that directly. But what I can do is I can say, if I use the sine rule, okay, then I need to know what this angle is over here. Now, can I work out what this angle is over here? Can I work out what this angle is over here, this whole of this angle? Well, yes, I can, because I know the whole of this angle, these two together. I know the whole of this angle, it's given. So this angle is 180 minus those. So let me call this angle theta. Let's say, let angle ABC be theta. So I have to keep writing ABC all the time. So I know that theta is equal to 180 minus the sum of these two angles, which is 42 plus, and you got 54 and this 29.503. Together, those two make that third angle. It's like these two together make that third angle. So therefore, that will give me the angle over down here, which is theta. So I can take this angle that I had before. I can add it to 54. I can add that to 42. Okay, and I can do 180 minus that angle. And that gives me 54.496. 54.4965. That's the angle over here. That's the angle that we found here. That's theta. So now I can use the sine rule. Now the sine rule states that the sine of an angle divided by the length opposite it will give you the same ratio for all three sides and angles in the triangle. So if I find the sine of this angle divided by 11, it will give me the same answer as the sine of this angle divided by y, which will give me the same as answer this whole angle, sine of this angle divided by this side. So if I do y divided by the sine of this angle, it will give me the same answer as 11 divided by the sine of the angle. So we can set it up that way. We say y divided by the sine of the angle theta, which we just worked out is 54.4965. I'm writing it to a high degree of accuracy. Why? Because we don't want to do premature rounding. We want to keep accuracy in our work. So at least to one more decimal place than you need, one more, higher degree of accuracy than you need in your final answer, you should write it like that. So it's over 11 equals 11 over the sine of the angle opposite, which is 42. Don't forget the sine of the angle. It's not 11 over 42, it's 11 over the sine of 42. It's not y over 54, it's y over the sine of 54.496. So therefore, y is going to be 11 times the sine of 54.4965 over the sine of 42. And then we can write this down, this answer down. So this is the answer that I got here. So I'm going to do 11 times the sine of our last answer all over the sine of 42. And we're in degree mode, of course. Press equals. It gives us 13.3828. 13.3828 goes on 3SF in the end because it's a length. So you have 13.4 centimeters, and that's the answer to part B or part 2 of question A, question number 6. Question number 6B is all about volumes, and I'm going to save it under a different video because I like to separate my videos according to topic as well as paper. So if you want to see 6 part B, you will have to go to the playlist that will appear at this section over here, and also will appear during the video at the top, and that takes you to the playlist for this paper. If you want to see other questions involving trigonometry in general, you can find the playlist for that for my IGCSE trigonometry questions there. If you want to specifically look at questions dealing with the sine and cosine rule, I have my playlist for my IGCSE questions involving the sine and cosine rule over here, and you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.